All right, great. So, we are here to learn statistics. Yay. Okay. Anyone take a statistics class already? Oh, what are you guys doing in this class then? Review. That was a long time ago? Is that the case for all of you retaking statistics? Okay. Alright, that was a lot more than I expected. Generally it's only like 3, but... Okay, well great. Then maybe you can tell me, why do we bother studying statistics? Lets you know what's normal. Okay. And by normal you mean ordinary and mundane, or normal like the normal distribution? Or I guess you could say both, because the...
normal distribution.
Okay, okay. So yes, statistics will allow us to know what is follows the normal distribution, which we will cover in a couple of weeks. And it also lets us know what is ordinary and mundane as far as data goes. Okay. Might not tell you well. Yes. Okay. Anything else? Yeah.
To understand data, or to kind of quantify things that are not easy to understand, also to predict.
Okay, yeah, these are great answers here. Okay, yes, to understand data or to quantify things, yes. So I would say any time you take a class, or a lot of classes that you would take, or any time you decide to learn something, oftentimes that thing will teach you to help you. I'm like garbled in my words. We study a subject like statistics to help us understand the world around us, okay? Okay, and that applies for many classes, okay? You take a science class, it will help you understand the world around you. History class, it will also help you understand the world around you by helping you understand the past. Let me put this in. Do that. Okay, and specifically, statistics allows us to make conclusions based on limited data. Okay. And what I mean by limited data is that we do not have all the information available out there in the world, okay? We are living in the information age, or whatever we want to call it, where we are generating tons and tons of data, okay? And if you have a cell phone, you are generating data just by sitting in this classroom. You might be giving off a GPS signal, it might be pinging a cell tower, and so should any of you be accused of something, if you listen to the Serial podcast, they said, you are here based on the cell phone tower pinging, whatever. Okay, so we're generating tons of data that may come to your defense or put you in question, whatever. Okay, so anyway, lots of data. But even with all of this data that we're producing, anytime we have a question, we will not have access to all the data that we might want, okay? So if we had a simple question, what percentage of the United States at this very moment is female? Okay, it's not a terrible question, all right? What percentage of the USA US is female? right now?
Between 51 or 55.
Okay, so we're getting answers, 51 to 55%, which is a little bit more bold than just saying around 50%, but it's that's a pretty good answer. But it's not the exact answer, right? What if I said I want the exact answer here? What pieces of information do I need to know?
Total population.
Yeah, to get the exact answer, the exact answer requires 2 bits of information which are, for all intents and purposes, impossible for us to obtain, okay? The exact answer requires the exact number of females alive right now, and the exact number of people in the US alive right now. Okay. So this is going to be, 301,658,000, something, it's going to be a big number, and we would need to know the exact number of people in the US alive right now. And does anyone know that number? No. No one in the world, no one knows that exact number. Because that number is changing every single second, okay? Because someone is being born or someone is dying. And, we took a census 5 years ago already. It seemed like it was not that long ago, but we took a census 5 years ago. All of that data is already outdated, okay? Because I think we can all think of somebody who has been born in the last 5 years and somebody who has passed away within the last 5 years. And so those numbers are outdated. So there's no way for us to get this exact number. And then there's also no way to get this exact number, okay? But if we wanted to answer this question, an exact answer would require both of these pieces of information impossible for us to obtain, okay? These numbers are impossible to obtain. Those of you in the back, am I writing large enough for you guys? Okay, I hope so. And I would encourage you to just move up a few rows also. And, I think it's better, okay? But, I'm biased, of course. Okay, so, well, maybe we don't need the exact answer. Maybe we're okay with a ballpark number. Okay, well, if we want a ballpark number, then we would need to understand statistics. And we must learn statistics so we can get an idea what our estimates mean. Alright, I probably wrote a little more than I needed to there. So yeah, we can say, well, the percentage of the United States that's female right now is between 51 and 55%, and that's most likely a true statement. But what exactly does it mean that it's between 51 and 55%? Well, that seems very clear right now, but we're going to learn how to make what we call a confidence interval, where we talk about creating a range, okay? Or someone else can say, well, the percentage that's female is 52%, give or take 2%. Okay? Maybe true, may not be true, okay? Someone else can say it's something around 50%, okay? So all of these things, you know, what exactly are these statements really saying, okay? Let's say we are from another planet, and we had this question, okay? We decide, for some weird reason, to go to the US and decide to say, well, what percentage of the US is female right now, okay? We're coming down in some spaceship. And we want to know the answer to this question, okay? And we say, oh, well, we don't need the exact number because that's going to take, it's going to be too hard to try to count all of the people, all right? So maybe we decide to randomly abduct 100 people, okay? So we take a random sample of 100 people. And then in this sample of 100 people, we count 52 females. And we say, okay, well, in my sample, 52% are female. Does that tell me anything about the percentage in the United States population as a whole?
No.
No.
I mean, well, what if you picked 100 people from outside of an OBGYN's office?
Okay, so well, I'm saying random sample. So somehow, I don't know, my spaceship is really awesome and I can get a random sample. I wouldn't even know how to do this, but you know, we create a map. Do 100 random points and we fly there and we pick 100 people at random. Okay, so let's say we managed to get a random sample. Okay, so we're not standing outside the OBGYN. Wherever there might be a skewed population of. Okay, so I get 100 random people and I find that 52 of them are female. 52% of my sample is female. What does this tell me about the U.S. population as a whole? Anything?
Out of every 100 people, you might find 52 female.
No. Okay. Well, I mean, I obviously did. So, yeah, it's well, it feels like, well, you can't say a whole lot. But it tells us that if we looked at everyone in the United States, that if I were to go for the exact answer is probably somewhere around 52%. Okay? So we would say, what does this tell us? Well, the exact answer will be around 52%. And after studying statistics, we will say, the conclusion that we would say is the exact answer is, let's say we believe the exact answer is between 42% and 62%. Okay, or basically 52%, give or take 10%. I mean, that's a wide range, but it also tells us a fair amount, especially if we are aliens on a spaceship who know nothing about the US population prior to taking this random sample. Well, now we have an idea that it's somewhere between 42% and 62%. We're pretty confident about that. Okay, so this is just a glimpse of where we might be headed in this class, okay? We are going to learn how to make conclusions about the population based on limited data, right? And so the idea is that we have something called a population. Okay, the population is a large entity, and this represents everyone that we might possibly want to study. Okay? So in our previous example, when we were talking about the percentage of the United States that's female, the population is everyone in the USA. That would be our population. And the population has a property that we wish to know, or we wish to make conclusions about. All right, and so in the previous example, the property, which we call a parameter, population has a parameter that we want to know about. Okay, parameter is basically a property of that population, and in the previous example, that parameter was the percentage that is female. But because of practical reasons, we cannot study the population directly. It's too big for us to study directly. Okay. So what do? Well, we don't try to study the population directly. From the population, we take a sample. Okay. The sample is a selected group. Is a group selected from the population. And we can study the sample directly, okay? And what we're hoping is that what we see in our sample tells us something about the population. Okay. So we're hoping that the sample we select tells us something about the population. But the only way for that to be true is that our sample needs to be representative of the population, okay? So we hope that what we observe in the sample tells us about the population, okay? And for that to be true, these lights are making me sweat or something. For that to be true, the sample must be representative. Of the population. So I'm kind of jumping into section 1.3 in your textbook, okay, where we're going to talk about sampling methods, okay? So how do we get a representative sample of the population, okay? Well, one way that should, not, it doesn't guarantee that we will get a representative sample, but based on mathematics, it should give us, in the long run, whenever we do this, we can just anticipate it being a representative sample. Okay. So one method that should, okay, and I'm going to write, does not guarantee, sample, give us a representative sample, I'm sorry. Is simple random sampling. Or SRS. Simple random sampling, okay? And simple random sampling plays a very key part in statistics, okay? A lot of the methods that we will learn assume that our sample has the properties of a simple random sample. And I'll talk about simple random sampling right here. But that could be a dangerous assumption, okay? Because if you apply the tests and methods that we learn in this class, which assume a simple random sample, but your data actually is not a simple random sample, the conclusions you draw could be wildly off, okay? So when we took the 100 random people from our spaceship, I said that that was a random sample, okay? If it was not, let's say we did go to the OBGYN and we abducted 100 people, okay? Well, we're probably going to get a lot of women. And if we assume that this was a random sample, then our conclusions will be wildly off. We would come to the conclusion that the United States is overwhelmingly female or something, okay? But that would be a serious mistake of assuming that our sample was random when in fact it was not, okay? And it seems like a very basic and obvious mistake, but sometimes a lot of people make these kinds of mistakes, all right? You know, the internet is notorious for people thinking they know more than they do. And so, you know, somebody might have a survey on a website, and they'll ask you, you know, what is your opinion on this, okay? And the survey comes out, you know, 90% say this, and this percentage says this, okay? Well, internet surveys, spoiler alert, are not random samples, okay? You can imagine the survey results on, you know, the presidential approval rating from a site like Fox News versus MSNBC or Huffington Post or whatever will have very different results because the people who go to those websites are going to be different groups of people. And for any one of those sites to assume or even claim that they're getting a random sample would be wildly mistaken, okay? So, for someone, you know, if one of those news sites, and they're generally smart enough not to do this, if one of those news sites published, you know, had a survey on their website or opinions, and then said, well, this is then how America feels, it'd be very wrong, okay? Okay, so let me talk about simple random sampling. Okay, so again, it does not guarantee a representative sample, but it should. Simple random sampling. Okay, and so let me just do my warning. Many of the methods we learn in class conclusions drawn So this is a good warning to heed. And anytime you read survey results in any kind of news article or whatever, you should ask, is this a representative sample? Okay, you should say, you know, is it possible that these survey results are just somebody asking, you know, they might say something like a non-scientific poll. And if you ever read an article and they say, oh, we've conducted a non-scientific poll, then that means everything you're reading here is pretty much gibberish, okay? Or, well, maybe not pretty much worthless, but it's, yeah, no better than just asking a few of your friends for opinions. Okay, so a simple random sample. The concept is simple, okay? Take a list of everyone in the population. Okay. That list is called a sampling frame.
Is this the same method?
Yeah, this is still talking about simple random sampling. This is how simple random sampling is done, okay? So maybe I'll write to do SRS. Just barely tall enough to reach there. Okay, so the list is called a sampling frame. And then, so you take a list of everyone in the population. Then, randomly select individuals from the list one by one. Okay. And that's it. That's how you do a simple random sample. And if you follow this method, then that means every single possible sample has an equal chance of being selected. The great difficulty of doing simple random sampling, can you guys see it? Is what? Getting this list of everyone. The random part is actually much easier than you might expect. Okay? Getting the list of everyone, that is very difficult. Getting a sampling frame that is everyone in your population is very difficult. Okay, a quality sampling frame. Okay, so quality sampling frame would be everyone in the population, meaning everyone can be selected. If I were to just ask you, you know, I need a list of everyone who lives in the city of Los Angeles. We're not even asking the United States. We're just asking city of Los Angeles. Could that be done? No. All right. There's just too many people, and too many people that are not accounted for. Okay. Maybe we can, you know, go get a list from the post office or something and by addresses, but then not everyone has an address. You know, not everyone's accounted for. It's very, very challenging. Okay, getting a list of everyone. A sampling frame that has everyone in the population is actually very difficult to do. Maybe we turn to, well, I don't know. What would you try to use as a sampling frame? Okay, so phone book, that's a suggestion, all right. Who here is listed in the phone book?
You use Facebook.
Okay, who doesn't have Facebook, right? A lot of people, right? So a lot of people, so we say phone book, nobody in this classroom, or hardly anyone in this classroom, would even have a possibility of being selected, okay? Because, you know, maybe 20 years ago the phone book was could have been almost a good sampling frame, but today, yeah, a lot of people aren't listed in the phone book. Facebook, as much as they would like to believe, does not have everybody, okay? It's not 7-something billion users, okay? You know, Facebook, only people who have access to the internet, which might be almost everyone in Los Angeles, but not really. You know, a lot of old people are not on Facebook, and a lot of young people, well, technically no one under 13 should be on Facebook, okay? Yes?
What about like birth records?
Hmm?
I was thinking like birth records.
Birth records? Okay, yeah. But that's not going to be everyone who lives in LA. That might be everyone who was born in LA that reported their birth, okay? So, yeah, very difficult to get a quality sampling frame. If you, maybe the most respected sampling organization in the US would be like Pew Research, okay? They do surveys and stuff, and if you ask them how they get a random sample, they do random digit dialing, okay? They just not literally punch random numbers into a phone and hope it rings, but they're doing something very similar to that.
Are they going through databases and picking phone numbers randomly?
They go through a database of switches, and they basically dial numbers at random. But yeah, that way they can still get like people who are unlisted and things like that. But even then, they're going to miss people who don't have phones. Yes?
Couldn't you use like doing research on like an inmate population for a specific jail, wouldn't that be adapted?
Okay, yes. Inmate population for a specific jail, you could get a quality sampling frame because the jail should know every single inmate in their custody. Otherwise, we would question how good of a jail this is. But yes, for something like that, at an institution, you could get a list of everyone. If you're going to a company and you go to the HR department, I need everybody on your payroll, they will be able to do that, okay? But anything larger than a single institution type thing, you're going to be running into trouble getting a quality sampling frame, okay? So this is the difficult part. If your sampling frame is not representative of the population, your samples will not be representative of the population, okay? Okay, so that's simple random sampling. It's always good to ask these questions. And at the end of the day, a lot of times we just have to accept that perhaps our sample is not a truly random sample. So this might, we have to heed this warning, but we might say, well, it might be as good as we're going to get, and we'll just have to live with that, okay? You're always going to have people who, maybe not always, but there are generally always going to be people who say, who are trying to live off the grid, where nobody has any record of them, okay? And yeah, those people are going to be difficult to get a hold of, okay? There are uncontacted populations in the world, and we have no idea how many people are in there, and we probably never will until, unless we violate the Prime Directive or something, that was a joke. Okay. Other methods. So that is simple random sampling. Sometimes we use other methods of sampling, okay? And I'm going to mention them here. We have something called stratified sampling. Stratified sampling, this is when we will use stratified sampling if we have a scenario where we don't trust simple random sampling completely, okay? So earlier I said simple random sampling should give us a representative sample, okay? And, if the entire US population is, let's say, 51% female, if I take 100 random people, I should get something around 51 females in my sample of 100. Okay, I might have plus or minus a couple females in a simple random sample. But because it's random sampling, it's possible that I get 60 females, or it's possible that I get 42 females, okay? Stratified sampling says, I don't want to mess with that, okay? If I get 60 females, that's going to throw everything off because I'm going to ask questions about related to gender issues, okay? So I don't want to get a sample that's 60% female. I don't want to get a sample that's 40-something% female. I want to get a sample that's 51% female. Okay, so with stratified sampling, when you select your sample, you make sure that 51 of them are female, 49 of them are male. Okay, so in stratified sampling, we know, quote no, the proportions of certain subgroups or strata in the population, okay? When we select our sample, we force our sample to have the same proportions. So, example, let's say the population is 51% female, okay, which implies 49% male, ignoring a minority of people who don't fit either category, but let's just say it was 51 and 49%. Then our sample, we force our sample to be 51% female and 49% male. Okay? We select from each subgroup at random. Okay? This does not avoid the problem that we have in simple random sampling. In simple random sampling, it's still dependent on a quality sample frame or sampling frame. Stratified sampling still requires that, okay? Because actually our sampling frame has to be even better. We need to know how many females there are and how many males there are. But we might do this. We have a question.
I don't understand why you would ever have to do that if it's based on something that you know already exists. If you have a random sample, isn't it?
So a random sample may not necessarily, if I select 100 people at random, I may not necessarily get 51 females and 49 males. Because it's selected at random, I could get, say, 60 females and 40 males. Okay? And let's say I was asking a question such as, you know, that we think may be influenced by gender. Okay, so let's say, you know, we asked the question, what do you think about Hillary Clinton running in 2016 or something like that? Okay, gender will probably play a role in that, maybe. Okay, and so if we don't want our answers to be influenced by just the fact that our random sample happened to end up more female or less female than what the population looks like, we might impose this kind of constraint. Yes?
So would you only use stratified sampling when it pertains to something less along the lines of, you know, population? Because you're clearly manipulating that factor in this example. So you wouldn't be able to use this for population, right?
No, you could, and because okay, so let's say just
Why
the question is, will you vote for Hillary Clinton if she were to run for president?
Well, that
okay?
makes sense using this sampling, but if you're trying to figure out the population of female versus male, and you're manipulating the proportions.
Oh, yeah, you would not, this is assuming you know something about the population, which is, we know that it's 51% female and 49% male. We would then not ask the question, what percentage of the population is
Right.
female and male, okay?
Right, okay.
But we might ask what percentage in the population would vote for Hillary Clinton should she run for president, okay?
Okay.
That might be. They had like a Hillary Clinton van or truck on campus the other day. I was like, whoa. Okay. All right. Yes?
So, by definition, stratified sampling doesn't mean that you're making them equal necessarily. It just means that you're making them something. like in this case, they're not equal.
Yeah, they don't necessarily have to be equal. You,
Okay, so that is-
yeah. In most cases, it probably, you know, unless something is equal in the population, you know. And you wouldn't do stratified sampling just because you feel like it, okay? Because it's more work, and you know, if your numbers are wrong, then you're gonna have more problems. You do it when you think the question you're asking might be influenced by the makeup of your sample, right? So if we think gender will influence the answer to the question, then we might want to make sure our sample has a certain proportion of each gender. Okay, so that is stratified sampling. We also have cluster sampling, okay?